In this video, we will look at quadratic equations and solving by factoring. If a, b, and c are constants and a is not zero, then the formula ax squared plus bx plus c equals 0 is called the general quadratic equation in X. If we use this to obtain a function, then what we obtain is known as a quadratic function. And that would look like this. So the following are examples of quadratic equations. Remember, the form is ax squared. Let's make that neater. We'll do ax squared plus bx plus c. So we must have the highest power 2 on our variable. And we notice that we do have that here. We do not have an x to the 1 term, but that's okay because this would really just be 5x squared plus 0x minus 2 equals 0. This still qualifies as a quadratic equation because it has x to the power 2. This next equation, 3x squared equal to x plus 4, is also an example of a quadratic equation of the form ax squared plus bx plus c equals 0 because we can rearrange this equation to put it in this form. So I will move my x term to the left side of the equal sign, and I will move my constant term to the left side of the equal sign, and my equation becomes 3x squared minus x minus 4 equals 0. And it does qualify as a quadratic equation because it has x to the power 2. This next example is also an example of a quadratic equation. We are looking for ax squared plus bx plus c equals 0. It doesn't look like it much yet, but if we perform the multiplication of these two binomials, we'll multiply x by 3x, we get 3x squared. We'll multiply x by minus 1, which is minus x. 2 by 3x, which is plus 6x. And 2 by minus 1, which is minus 2, and this still is equal to 0. We have a couple of like terms, so we will combine those. We get 3x squared plus 5x minus 2 equals 0. And yes, this is a quadratic equation. We do have x to the power 2. So this does satisfy the quadratic equation requirements as well. The following are not examples of quadratic equations. Notice we're still looking for ax squared plus bx plus c equals 0. We must have x to the power 2. We do not have that here. If I was putting this in this form, I would have 0 x squared plus 6x plus 1 equals 0. And the restriction that we had right from the very beginning is a cannot be equal to 0. So this is not a quadratic equation. In the one below, we notice we do have an x squared term, but we have an x cubed term, which is too high for a quadratic equation. So this is not a quadratic equation either. Next, we will look at finding solutions to quadratic equations, and we call these roots. There are 2 roots for a quadratic equation, and at times these roots are equal. That's fine, but there will be 2 roots. We will solve a quadratic equation by factoring. And what we are looking for when we are finding the roots are the 2 values of x that produce a y value of 0. And so these are the intercepts, the x-intercepts of the quadratic equation. Let's take a look at solving this, first by factoring the equation, and then we will see what I mean by setting it equal to 0. So if we think back to factoring, we are looking for two numbers over here whose product is negative 18 and whose sum is plus 3. Okay, so think about the numbers 18 and minus 1, minus 18 and 1, 9 and negative 2, or negative 9 and positive 2, 6 and negative 3, or negative 6 and 3. And then thinking about that, what the sum has to be, I'm stopping at 6 and negative 3. Because if I add these two, 6x plus negative 3x, I will get positive 3. So this is my pairing. I will factor my x squared this way. So my 3x gets broken into two separate terms. And I can put my negative 3 term first or second. It doesn't matter. I'm going to put it right here. Negative 3x plus 6x. And we could have done plus 6x minus 3x. Whatever you choose. It doesn't really matter which order it goes in. And so this here is, and we have negative 18 equals 0. This is the part that is equivalent to 3x, right? Negative 3x plus 6x. When you're doing this, if you want to double check, just stop there and make sure that you have equivalency right there. Now I factor the first two terms, find a common factor in the first two terms, and that is x. I'm left with x minus 3. Look at the second two terms, find the common factor, and it is plus 3 and x minus, plus 6 actually. 6 and x minus 3. It's still equal to 0. Which means we have x plus 6 and x minus 3 equals 0. All right. If you want to follow the pattern, you can go straight to that, but I recommend that you don't do it all the time, only if the coefficient on x is a 1. Then you can use that pattern. So now how is this equation going to be true? X plus 6 is a product, or it's a binomial, multiplied by another binomial, x minus 3. And somehow we get 0. Now, what do you know about all factors whose product is 0? At least one of those factors must be equal to 0. Both could be 0 because then it's 0 times 0. So we were doing 0 times something. That'll get us a 0. We can also have some number times 0. That'll get us a 0. Or we have 0 times 0, which gets us a 0. So we have two possible solutions. We have to set each of these two binomials equal to 0. We say x plus 6 equals 0 and x minus 3 equals 0, and solve x equals negative 6, x equals 3. The roots of this quadratic equation are 6 and, actually, I missed the negative 6 and 3. In this next example, we'll take a look at factoring to find the roots, and you'll notice that the difference here is the leading coefficient, which is the a, or the coefficient of the x squared term, is not a 1. I will still set up my little table. I want to have two numbers whose product is negative 8 multiplied by 6, which is negative 48, and whose sum is negative 22. So the process is factor 48, negative 48, go through and see what are the factors of negative 48. And as you write them all down and you find the sums, you will find the one whose sum is negative 22. And I'm going to say negative 24 and positive 2. Negative 24 times positive 2 is negative 48. And negative 24 plus 2 is negative 22. So there we have it. We will write this out. 6x squared minus 24x plus 2x minus 8 equals 0. This is where I encourage you not to just put them as x minus 24 and x plus 2, okay? This is not how this one works out. So only do that when the leading coefficient is 1. When it's not 1, we want to substitute the middle term with 2 terms, like that, as long as we have them equal. And we want to factor the first 2 terms. Find the common factor there of the first 2 terms. And I have a 6x, x minus 4. And then we factor the second 2, or the last 2 terms. And we have, let's see, plus 2, x minus 4 equals 0. We always check to see that we have the same thing in both brackets. And you can double check when you do the distribution that you get the 2 terms above. But anyway, my 2 brackets are 6x plus 2 and x minus 4. That all equals 0. So this is just like factoring that we did before. Now we use these factors. One of these, or both, are going to be set equal to 0. 6x plus 2 equals 0, and x minus 4 equals 0. And solve. 6x equals negative 2, x equals negative 2 over 6, which is negative 1 over 3. And on this case, x equals 4. And there we have our roots. X equals negative 1/3 and x equals 4. In this next example, we have a quadratic equation in which the c value is equal to 0. And this actually makes it a lot easier. We factor still, look for the common factor. We don't have to use our other factoring methods because there are less terms. So look for the common factor. That'll be 4x. We're left with x minus 5, and it's still equal to 0. That's what we're looking for right there. And so the same is true to find the roots. Either 4x equals 0 and or x minus 5 equals 0. We will say x equals 0 over 4, so x equals 0, and x equals positive 5. These are the roots. I have one last example involving fractions within the equation. Let's see. To remove the fractions, first we multiply by the lowest common denominator. And actually, the lowest common denominator is going to be equal to the product of the 2 denominators and then any common factor taken out, which there aren't. So the lowest common denominator in this case, x times x plus 2. So let's multiply through each term by the lowest common denominator. And I'll use some color in there. I've got 1 over x. And let's just put that in blue. We'll do x times x plus 2. And for the next one, plus 3. X times x plus 2, which equals 2 over x plus 2. I'm going to bracket it. You'll see why in a moment. And it's being multiplied by x times x plus 2. All right. I've done a perfectly legal thing to this equation. I've done the same thing to each term, just multiplied each term by the same values. So we have the same equation. Let's do some canceling. X cancels x there. No canceling in the second term. And x plus 2 cancels that x plus 2. So let's simplify. In the first, we have 1 times x plus 2, so just an x plus 2 there, plus 3 times x plus 2. So I'm going to multiply just to save a line. We'll do x times x squared, and then we'll bracket it first. And x times 2 equals, and I multiply 2 times x. That looks a lot better. When you get rid of the fractions, it looks so much better. Let's continue. Simplifying, I've got x plus 2 plus 3x squared plus 6x. I'm moving my 2x over, so minus 2x, and we'll have it equal to 0. Gather like terms. 3x squared goes first. Let's look at the x terms. There's one there, and one there, and one there. X plus 6x is 7x, minus 2x is plus 5x, plus 2 equals 0. Okay, all that to get it to a state where now we can factor, all right? So factor. I am looking for what? I have a leading coefficient other than 1. So I must multiply the 3 by the 2. I want two numbers whose product is 3 times 2, 6, and whose sum is 5. All right. Whose product is 3 times 2 and whose sum is 5. So we can think about, okay, 6 times 1, 2 times 3. All right, well, 6 times 1, that sum is 7. That's not right. 2 and 3, that sum is 5. Right, we're right there. Let's write that one out. 3x squared plus, we can do 2x plus 3x plus 2 equals 0. We go back and find the common factor in the first two terms, and that is x. We are left with 3x plus 2 plus, oh, no common factor in the last two terms. So 3x plus 2 equals 0. That means we have 3x plus 2 and x plus 1 equals 0. So now we have two binomials. The product of these two binomials is equal to 0. So each one we set equal to 0 and solve. 3x plus 2 equals 0 and x plus 1 equals 0. Solve these, we get 3x equals negative 2, x equals negative 2 over 3, and in here we have x equals negative 1. And there are the roots, right there and there. That's all my examples for that. Thanks for watching.